All right. Okay. So today I want to show something that I have discovered maybe 3 or 4 weeks ago, which is basically GraphQL. I knew that it exists for many months already. I tried it many months ago and I failed because I was too stupid to use Relay. And then I ranted on Twitter about it, why is it so difficult? And then everybody said, yo, why don't you just try Apollo with GraphQL? And then a few weeks later, you know, I had some time and I tried again, and suddenly it all came together and it worked pretty nicely. And after learning about it 2 weeks ago, we are already having some components on our production websites running in production. So, you know, I work for this online art gallery called The Artling and this luxury marketplace called LuxLove. And basically, just 2 weeks ago, I learned about GraphQL, and I'm like, okay, let's build a make an offer model here and build this thing in ReactJS and use GraphQL for the endpoints and Apollo on the front end. And this worked so well that we basically decided to migrate our entire API for LuxLove away from Django REST framework, so it's a classic REST API, and towards GraphQL. Let's see if I can. So this is basically our current API, and this is only half of it. I was pretty bad at making sure that all my endpoints are actually documented. So you would have to click into it. Sometimes these even crash if you're not logged in, or they load very long because they are loading 10,000 products and it crashes the browser. And then, you know, this is how you could see what kind of fields you can post and how the result looks like. So my current workflow is essentially, I want to write some front-end components, and I'm asking myself, which endpoint do we have that gives me that data, right? And then I go on to this website here, and I try to find that endpoint. Sometimes it's not on here, so I have to open up in Django my urls.py file and try to find the route in my URLs file, and then go to the API view and then see what the view actually does. So it's a really painful process, which is partly my own fault because I'm not documenting my API correctly. But it also kind of shows that even though Django REST framework is a fantastic framework, it's not easy enough, right? You as a developer, you can still fail. And GraphQL kind of, I think, solves that problem. So I will show 2 parts today, and I will show a lot of code. So if you want to try this at home, you can essentially go to this repository on my GitHub account and simply follow the same, it's like basically these are my slides here. You just follow this thing and you copy and paste all the code, and hopefully it works. I mean, I will show that it works right now, so anyone should be encouraged to try this as well. Or, you know, you can just clone the repo. The repo already has the final state. So when you clone this and you run pip install for Python and yarn install for the front end part, you should have the final version up and running, and you can just start playing around with it and manipulating it. Okay? All right. So, so for those who have not used GraphQL before, I'll give a very quick intro. So it's a query language for your API. So what does that mean? It means that we are writing queries like this. We are not calling API endpoints anymore. There's only one API endpoint, and that is your GraphQL API endpoint. Like with normal REST APIs, we have dozens, if not hundreds of API endpoints, right? With GraphQL, there's only one, and we send post requests to that endpoint, and the data of the request is simple text queries like this, right? And the data that we get back looks exactly like the query that we have sent. So it's, I mean, you don't need to know anything about relational databases, about SQL, or this kind of stuff. It's pretty easy to understand for pretty much anyone how to access the data, right? On the back end, you might have different data sources. You might have a MongoDB, you might have a PostgreSDB, you might pull some data from the Twitter and Facebook API, and you all wrap it in your GraphQL schema. So your user, the developers that build the front end, they don't care where the data comes from. They just say, like, give me the user profile and the name, the first name, last name, email, and avatar picture. That's all I care about. Where it comes from, I don't care, right? Another good thing is that if you use something like Relay or Apollo, it groups all your queries. You might have dozens of components, and they all have their own queries. it groups them all together into one request and sends only one request to the server. The server does all the database fetching and sends one response back to the client. So you save a lot of bandwidth. Okay. So the main task when working with GraphQL is you have to describe how your database schema looks like. Okay. So you will have. So this is the GraphQL schema, and by defining this schema, by saying in my application there is something called character. There's something called planet and so on. When you define this schema, there's this editor here, graphical, that has autocompletion. So because the schema is predefined, the editor can fetch the entire schema and know about it. And while you're typing, it autocompletes. It knows which endpoints exist. It knows what is the return value of each endpoint. It knows what fields are available for the user profile object, for example. Maybe they show this here. You can even click here at docs. It shows all the endpoints that exist. If you click into an endpoint, it shows what is the return value and what fields are available on the return value. So API documentation, 100% done. Always up to date, right? You cannot fail as a developer forgetting to update your own documentation, and then you stop using it, and then you have to go back and read your ugly code, right? Okay, so that's basically the idea of GraphQL. All right, so let's start totally from scratch, right? You want to, build a GraphQL server on the back end using Django, and you want a ReactJS application on the front end using ReactJS and Apollo. So that's our goal for today. And I already prepared this because I don't want to download things. I don't know how fast the internet is here. So if you started a new Django project, you would create some folder on your machine. You would start a new virtual environment. Then you would run pip install Django, PyTest, PyTest Django, PyTest coverage, and mixer. So I like to do stuff in a test-driven manner. Lots of people who already saw the other two talks that I gave about this asked me, how do you test this? So I'm trying to show this today as well. And when you have Django installed, you can run on your terminal Django admin start project, and you give it a name. And I like to name it backend in this case. So when you run Django admin start project backend, it would then create this backend folder here and put a few files inside. Okay. Right. So it looks like this. And when you created a new Django project, you first want to migrate the database so that all the tables that are built into Django will be created. And then you want to create a super user so that you can log into your own admin interface. You call an admin. Right. And then you can run the development server. And if that worked, you should be able to go to localhost 8000 and you see this default Django page that every empty Django project shows. Okay? All right. So since we do stuff in a test-driven manner, I have a few patterns that I always use in all my projects. So we will need a test settings file. Basically, we are overriding some things from the Django settings, and we are saying we don't use whatever database your Django installation is using. We want to use an in-memory SQLite database because it's much faster. Then the test will be like 10 times faster than versus using your real Postgres database, right? Same here for the password hashers. In your tests, you will usually create lots and lots of users. And usually in the beginning of each test, you have to create a user so that you can attach it to your request and then call your views. With the SHA password hashing, which is the one that you should use for your real installation, it's a bit slower than just using the MD5 password hasher. And same here, if you have any models that have files, data like images or file fields, you can use in-memory storage so that these don't really get written to the disk. So you save I/O operations, tests get faster again, right? So this is a simple test setup that's useful for pretty much any Django project. So I like to use not the built-in Django test runner. I like to use PyTest, and for this we will need a pytest.ini file. We basically just tell PyTest where our test settings can be found, the file that I just created. And then I like to have 100% test coverage in all my projects. So we also create a coverage RC file. Basically, this file only is a list of files and folders that I don't care about, where I don't care about the coverage. You know, the manage py file, the wsgi.py file, they are pre-generated by Django. I don't put any code in those files, so I don't want them to reduce my coverage because I'm not going to test these files. The coverage in those files will always be 0%, and it reduces my overall coverage. And I want to have 100% coverage, so I add these exceptions here in the coverage RC file. So at this point, hopefully, I should be able to run. Okay. Should be able to run PyTest. Yeah. I don't have any tests, so it doesn't generate a coverage report right now. Okay, so that's like you just created a new Django project, you set up your testing framework, now you are ready to get some real work done. So the first thing that I usually do is I create an app. So in Django, those people who haven't used Django before, you basically, so this folder here, backend, this is my entire Django application, right? This other folder, which is also called backend, is kind of my project folder. This folder usually only has project-wide settings. We have the test settings in there, and we have the main URLs type in there. So there's this file here, URLs type, which shows all the URLs that are available in my application right now. And all the real logic, all the the meat and bones of my application should be sliced down into small applications. Right? There will be an application that deals with products, one application that deals with user profiles, one application that deals with, I don't know, all kinds of things. Maybe currency. I just built one for multi-currency support. So I try to separate small tasks into small apps, right? So I just created an app. So you would do a Django admin start app, and then you give them the app name. So that's just called a simple app. The first thing that you do usually in your app is, okay, wait. Before I move on, because I'm doing test version development, I create a test folder, and I turn this folder into a Python module, and I put a test_models file in there. Preparation for later. And every time you add a new app to your Django project, you have to go into your Django settings file and put the name of the app into your installed app settings. Otherwise, Django will not know that this folder is a Django app. It will ignore the models file inside, and the application will not work properly. So with this preparation, we would be able to create our first model. So whenever we create a new app in Django, usually the first thing that we want to do is we want to describe what kind of database table this application has. So let's say for today we built a little Twitter-like application where people can type messages, and then on the home view you have a long list of messages, right? And you can click into the messages for the details. So we will need a table called message. So in Django, you basically just create a class called message, which derives from models. And these are the fields, the columns of our database table. Okay, so each message belongs to a user. Each message can have some text and a creation date. All right? So it's a pretty simple database with 3 columns. Database table with 3 columns. Usually, I wouldn't do it this way. I would first write the test, but I think it's easier to understand when you see what we are trying to test first. A test could look, so for each file, like I have a models.py file here, I will also have a corresponding test underscore and then the file name. So later we will have a schema file, and we will have test underscore schema. In most of my projects, I will have a utils file, and I have test underscore utils. For every file that I make, I have a test file, right? And for every class and every function in all of my files, I'll write a test. So we have a message class here. So we will write a test message test. So this stuff is basically boilerplate stuff that we need so that we can write into our database, because PyTest by default does not allow you to write into the database. But when you import PyTest and then you make you call this pytest.mark DjangoDB, then you can write into your database. Mixer is a very, very useful tool in the Django ecosystem that allows you to create test fixtures. Because usually when you write tests, you need to make sure that your database has certain objects. There needs to be something in your database, and then you can run your test and see. Like, for example, when you want to test if a view deletes an object, you need to create the object first, and then you can test if the deletion works. And then afterwards, you check if the object is still in the database or not, right? So I always use Mixer to create objects in my database. And Mixer basically has a very simple API. You call mixer.blend, and then the name of the app and the name of the model that you want to create. And Mixer will basically fill random values into all fields. And this is the cool thing about Mixer. So it even understands if it's an email field, it will put random emails into that field. And if it's a name field, like first name, last name, it will actually put out of a dictionary of names, random names into that field. And the good thing is sometimes it even puts Unicode characters, like Chinese words, into text fields, which you never test. And often you have Unicode decode errors in your application, and you will only realize after running your test suite for a few times, you will realize that there are some bugs in your code because Mixer was putting Unicode characters into your text field. So it's a really cool project. So I just try to instantiate a message object, and I check if it has a primary key greater than 0. That means it's in my database. If the object is not saved to the database, the primary key would be none. Okay? So this could be a possible simple test, how to just test a Django model. I mean, there's nothing much to test anyway. The model doesn't have any functions. It's not doing much. Yeah, I just write this test essentially to get 100% code coverage. Okay? So we have our model, and we also want to be able to use the Django admin to fill in some messages into our database. So I register this model with the Django admin. And now, at this point, I can create an initial migration. So basically, I have created a new database table, right? Django has this feature here, make migrations, that will create the insert table statements for me. So when I deploy this application, it will also update my database immediately, automatically. Migrate. Okay, so at this point, server is still running. I should be able to log into my admin, and I can see my messages table, and I can fill in a few messages. Let's fill in 2. All right. So now we have 2 objects in our database. Okay, so far this is like the super quick introduction into Django for those who have never used Django. Now comes, for those who have used Django before, now comes the exciting part. Let's try to use Graphene Django. So Graphene is a pretty cool Python app that allows you to write a GraphQL schema in Python by writing Python classes. And Graphene Django uses Graphene to have some even more integrated stuff so that you can use it super easily with Django. And it basically understands your models and creates the Graphene schema based on your model fields, right? Very similar, for those who have used Django REST framework, very similar to writing serializers. For each model, you usually write a serializer so that all the fields on your model can be returned to your front end as a JSON string, right? Okay, so you would have to do pip install Graphene Django, and every time we want to use a new app in our Django project, we need to add that to our installed apps setting. And Graphene needs one more setting. I shouldn't have closed that off. It needs to know where is your main schema file. That's pretty similar to the urls.py file. There is one main URLs file that imports all the other ones from your applications. And the same thing is true for Graphene. We will have one main schema file, which is in backend/backend. Let me just create the file already. Schema.py. Okay. And the code in that file looks a little bit like this. So we say, this is our main schema. We have to read it from bottom to top, basically. This is our main schema variable. This is the variable that this setting is referring to, right? In backend.schema, so backend is the folder, schema is the file, and schema is the variable. And the schema has this queries class. Right now, I don't really have any real endpoint. So I just put, you have to put something here. You cannot do this. You cannot just have pass and do nothing in this, sorry, and do nothing in this class. So I put a dummy endpoint there. Essentially, we have now one API endpoint that's called dummy, and that always returns an empty string. It doesn't do much. So later we will not need this anymore. For now, I need this so that I can go on to the next file. Oh yeah, we will have to replace, we will have to add 2 more endpoints to our URLs. So GraphQL is the editor that we will use during development. Probably in the real world, if you deploy this, you would only hook up this endpoint when debug is true, for example. You might not want that anyone can go to yourdomain.com/graphical and then start exploring your API. And GQL is actually the same view, but this is going to be used by our front end using Apollo. Yeah, so this comes with Django Graphene, these 2 endpoints. So at this point, if everything worked, let's see, server is still running, I should be able to go to this graphical endpoint. Yep, and thanks to the code completion, it already tells me that there is an endpoint called dummy. Whoops. So let's say I want to query dummy, and it always returns null. Because we haven't really implemented, we said the type of dummy is a string, but we haven't really written a resolver function, so it's not really returning any string. It's currently just returning nothing, okay? So don't worry about this dummy endpoint. We will have more meaningful endpoints later. Okay, so I said that writing these schemas is very similar to writing serializers in Django REST framework. And so basically what we have to do is, in our simple app, we will also have a schema file. So, and we have to, for each model that we have, so we have a message model, right? We will create a message type. So for each model, we have to create a Django object type class. And the syntax is always the same, like you have like class derived from Django object type, then class meta, and then you say which model is it and what, and it's always interface graphene.node. And then my app, so this is in my simple app folder, right? My app has its own subquery, okay? And here we say we want to have an endpoint that's called all messages, and that returns a list of message type objects, okay? And then usually when you write these endpoints, they always come in 2 pairs. One is the name and the type, and then there's a resolver function that has the same name, like all messages, but resolve underscore prepended to the name of the endpoint, okay? And essentially, args is post parameters. If your client wants to post some data to the endpoint, this will be hidden here in args. So in normal Django views, this would be request.post, right? The data inside, the post data that's posted. Context is, in this case, in Graphene, is the Django request. I could actually, call this request, and then everybody who knows Django knows how to use this. You have request.user is authenticated and all these things, or request.session and so on, okay? I just leave this. Because the Graphene docs don't assume that you are using Django, and in their examples it's called context, so I just kept using the same. Okay, so now we created a new endpoint, but this endpoint will at this point not be visible yet, because in our main schema file, we need to import it. So we do import simple app schema, and then we use multi-inheritance here, simple app schema query. And now we don't need the dummy anymore, because now we have an actual endpoint, so we have our subquery here, which is abstract type. So this query alone cannot be used. But when we combine it with Graphene object type, so using multi-class inheritance, now we have a query that can be used for our Graphene schema. All right. So basically, in this file, every time we add a new app to our project, we will just keep importing the apps here, and then we will keep adding. We will keep adding those query classes to our main query class. Okay. All right. So at this point, we should be able to see the endpoint all messages, and it also knows that it returns lots of messages, and messages have a field called ID, and they have the actual text called message. I can run this query, and I'm getting the 2 entries that are already in the database. Okay. And by the way, the docs are always up to date. It tells me what queries are available, all messages. It tells me the return type of message, and it tells me these 3 fields are available on my return type. Okay, so we did this already. We tried the query. Okay, let's create one more endpoint. One endpoint that returns a single message and not all messages at the same time. So I will explain this later. Okay, let's not worry about it. So my endpoints always come in pairs, right? I have the name of the endpoint and the type, and I have the resolver function. I just keep adding them to this query here for this app. So now I'm saying the message endpoint is just one field of message type, and if you want to call it, you have to provide an ID of ID type. So this ID type is something that I don't fully understand. It has something to do with GraphQL and Relay, how they deal with IDs to identify what's already in the cache and what not. I won't say anything more about it because I don't really understand how it works. So you can already see here when I queried all messages, they don't have the Django primary key, which is just 1, 2, 3, right? They have this weird stuff here. This is like some hash value. If you unhash it, you get a tuple with message type, the name of our type, and the primary key. So it's like somehow encrypted, but the information is still there. And the theme gives us functions to turn this string here back into a Django primary key, or message type and primary key into one of these weird strings. Okay. So in my resolver function, I'm essentially, I know that the ID that I'm getting here will look like this, right? So first, I will use the from global ID function to turn that ID into this RID tuple. And the second item in the tuple is my actual primary key. So then I can use the Django, the usual way how you get data out of the database in Django, message.objects.get the object with primary key 1. Okay? So when I update my schema like this, I have to reload. So I have to reload my editor. Now it has all messages and it has messages. And it also tells me that it requires one parameter ID. Okay, I need to copy and paste one of the IDs first. So let's see all messages. I want to get this one. Message is this. And voila, I'm getting my data. So now I have an endpoint where I can query one single item. Okay? So the final piece of the puzzle is we know how to read like list views, we know how to read detailed views. Now we want to know how to write into the database. In GraphQL, this is called mutations. Okay, everything that changes data is called a mutation. And let me just add that to our schema. So okay, we read that from bottom to top again. Similar to how we have lots of queries, right? We have query all messages, we have query messages. We will have lots of mutations. So this mutation is going to be called create message, and it's of type create message mutation. So here it's different. We won't have resolver functions because mutations are a bit more complex than just a simple function. We will have mutation classes. So how does a mutation class look like? It has to derive from graphene mutation, and it has to have this subclass input. So obviously we want to create a message, so the user has to type in a message. So we need to get message as part of the post data, right? And mutation can also have output. So and this is tricky to wrap your mind around. When you are used to REST APIs, you know, like, if I call this endpoint and I do a post request, right? This means the endpoint is supposed to write data to my database. If my form data is wrong, the endpoint will return 400 status code and say this was a bad request. There are some bad form values. With GraphQL, you don't have that anymore. Every request is a post request. Every response is a 200 response. And either GraphQL was able to give you the data that you asked for, or it wasn't able to give you the data that you asked for. So it's up to you how in your front end, how you figure out if there were form errors, if the data that was requested, if you are even allowed to see it, and so on. Okay. So I came up with this for now. I will always, when I have mutations, I will always return a status, which is just it's like the usual HTTP error, HTTP status codes, right? I will have form errors, which is supposed to be a JSON string of my fields and the corresponding errors. In the same way, like Django REST framework, if you call your serializer and the serializer is not valid, you can return the form errors of your serializer, and on your front end you will have a dictionary with the field and a list of errors for that field, right? So I will just make sure that I design my form errors in the same way. And if the mutation was successful, I'm going to return the newly created message. So this is a graphene field of type message function, all right? And then for each mutation, you have the mutate function. So, and here you can do things like checking if the user is even allowed to do it, right? So it's this, I told you, args is the post data, context is the HTTP request. So we can check if context.user is authenticated. If the user is not authenticated, and this is the funny thing, we don't return HTTP values like in Django or in Django REST framework, right? We return an instance of this mutation class itself where the corresponding return fields are set to some value. So in this case, when the user is not authenticated, we will return the create message mutation, and we will set the status to 403, which means forbidden. So that means there will be no form errors, there will be no message returned, and we won't have created anything in our database. We just return 403. On the front end, it's up to you how to deal with that. You will probably redirect to the login view and ask the user to log in, right? Or if the user is already logged in, you will say that you are not allowed to do this action. Then we will probably do some kind of form validation. We will check if the message is empty, and if the message is empty, we return an instance of the mutation, and we will set status to 400, which means bad request, and we will return a JSON dictionary where we say the message field had an error, and the error is please enter a message. Okay? If everything is fine, we will use Django to create our message, and then we return, once again, like always, we return an instance of this mutation, and the status will be 200, there will be no form errors, and message will be set to the newly created object. Okay? So basically, if you are used to just writing normal Django views, this is your Django view. This is what you used to do in your Django views in the post part, right? Or the resolver functions. It's what you used to do in the dispatch function or in the get function of your Django views. Or if you are used to Django REST framework, this is what you used to do in your API views and in your view sets and so on. Okay? So this is where all your logic is. And it's just normal Django code, like you always used to write Django code. It's nothing special. All right, so now we have this mutation. Let's have a look at test, because it might not be super obvious how to test this. Oh yeah, I need to create a new file. Test schema.py. So just quickly, people ask me, how do I test this? And it couldn't be any easier. Oh wait, I forgot some imports. From mixer, backend, Django mixer, and then from So our mutation does three things. Are you logged in? Did you provide a message? And then it creates the message. These are the three situations that can happen, right? So you would want to write tests for that. So the first test would be, you have correct data. The message is there. You create a request using Django's request factory. You attach an anonymous user. You can import anonymous user from Django to that request. And then you simply create an instance of your mutation. I mean, it's just a class, right? The create message mutation is just a class. You can create an instance of that class whenever you want. So we have an instance here. And the mutate function is just a function. So you can just call that function on your instance. And we know that the first thing is supposed to be, root. I don't even know what root is. So in my test, I simply pass in none, and it still works, you know. Then the second parameter is supposed to be the post data. So we put in the data that we've constructed here. The third parameter is context/request. So we put in our request here, and then we just check if the result that we get. So the result that we get is a dictionary which has these three fields, right? And if the user is not logged in, the field status is set to 403. So you can simply check for that in your test. You check if result status is 403, right? So the next test will be, now we don't have anonymous user, we have a real user attached to our request, but we don't provide any data anymore, right? Now the status should be 400, and we should see if message is in the form errors JSON string, right? And finally, we will have the same logged in user, and we will call the mutate function passing in an actual message, and now the status code should be 200, and I should update my slides because they were so wrong. Should return 200 if everything is correct. And we check if we got a message as a return value, a message instance, right, with a primary key. So it means it has been saved to the database. So this is how you could write a test for mutation. Simply instantiate the class and call the function. And the same is true for queries, right? You can instantiate this query and you can call the resolver functions and simply test what you want to test. So testing couldn't be any easier. Okay, so we have the mutation in place. Now we need to hook it up in our main schema file, just like we hooked up our queries. Okay, and at this point, thank God it works. Now the editor knows that there is a mutation, and it's called create message, and you have to provide a message. And okay, let's try an empty message, and we get status 400, form errors, please enter a message, right? If we provide an actual message, we know that we expect that we will get back the message object, and the editor can go deeper and deeper. It knows that messages of type message type, which has ID and message. So I might just want to query that from my return value, and I'm getting status 200, no form errors, and a new ID and a new message. And it has now actually been saved to our database. Right? When we look back to our Django admin, there should be 3 messages now. Okay? So final thing, and then I think we can have a short break. Authentication. Everybody asks me, cool, this is so cool, but how do I do authentication? So there is something coming up, Django GraphQL. I haven't had the time to really look into the code of this repository, and it seems to be a little bit stale. There wasn't any work recently, and they say it's based on Django REST auth. So I'm like, why don't I just use Django REST auth then, right? So I kind of decided against this. There's also Python JWT, which is like the Python implementation for doing JSON Web Token. You could probably write your own mutation, you know, that accepts username and password, and then looks it up in your database. If it's correct, then generates, encodes a token like that and returns the token. But, you know, I'm not really a cryptography expert and so on. I will probably write something that can be exploited, so I didn't have the balls to do that. There is Django REST framework, JWT, which I know has, you know, a lot of watchers and stars. Recent development 5 days ago, Django REST Framework has a huge community. Most of the people are probably using Django REST Framework JWT as well in their projects, so I felt more secure using this. Unfortunately, this is not using GraphQL, okay? But I thought, okay, then I have an API that has the GraphQL endpoint and 3 more endpoints for token management. Who cares? 4 endpoints in total is still a super easy to understand API versus my current API with 300 endpoints, right? So I thought it's a good trade-off using something that's very well tested, but isn't using GraphQL, but it works, okay? So you would run pip install Django REST Framework, Django REST Framework JWT, and Django course headers, and then add these two to your settings. All right. And then Django REST Framework needs a bunch of settings, and we will just add. And for local development, we need to make sure that, because our backend, our frontend has different IPs, so it's like different origins, and usually the Google Chrome browser would prevent you from sending requests between the two. And then we need to add the course headers middleware to our middleware classes. All right. And thanks to Django REST Framework JWT, we have a few new URLs that we can hook up in our main URLs file, which is essentially these 3. And these are classic REST endpoints that most people will have in their classic REST APIs. So these 3 APIs will help us to authenticate and get a token. Okay. Okay. When we did this, we should be able to use curl. Our user is called admin, password is test1234. The endpoint is called AP token auth. So hopefully, if this works, we should be able to send a post request with our username and password, and we will get back a JSON web token that is now valid for 5 minutes. All right. So this is the first part. Should we have a short break? I mean, there's still a lot of food there. Maybe we, get some drinks and we do a 5-10 minute break. You can ask me some questions over there, and then we just return here and get to the more difficult part, to the front end part. Okay. So thanks so far.